Hello and welcome back. This is a video over section 3.2, and we're going to be talking about polynomial functions and their graphs. The first thing I want to do is talk about a couple of things. I want to talk about the concept of end behavior. All right, and end behavior is, what does the graph do? So what does the graph do when x goes to positive or negative infinity? All right, so we've got four options of end behavior if we're talking about polynomials, okay? So the first one that we have, we look at our leading coefficient, okay, and we look at our degree, okay? Our leading coefficient is the leading number out in front of your variable, okay, and the degree is your largest exponent, okay? So what I have is I have a couple of options. If your leading coefficient is positive and your degree is even, okay, then your graph is going to behave as such. You're going to have a graph whose end behavior goes up to the right and up to the left, okay? If your leading coefficient is negative, okay, and your degree is even, okay, then your end behavior is going to go down to the left, down to the right. Okay, similarly, if you've got a leading coefficient that's positive and your degree is odd, all right, so then you would have go down to the left, up to the right. Okay, if your leading coefficient is negative and your degree is odd, then you go up to the left, down to the right. Okay, and you can look at, there's a couple of functions that you can look at. You know, when I think of these, I think of the graph of f of x equals x squared, okay, where my leading coefficient is positive and my largest exponent is even, and that's a parabola that's going to open up like that. Okay, to think about the opposite of that, okay, f of x equals negative x squared, then that graph is going to open down. Okay, and that's going to be your end behavior. The one over here, f of x, to have a degree that is odd would be x cubed, okay, and your graph is going to kind of look like that, and then if you switch it around and go the other way, you're going to have negative x cubed, okay, it's going to go that way. So that's what I think about when you're talking about leading coefficient, and this is your leading coefficient test, okay. The next thing that I want to talk about are zeros. So up here, I'm going to talk about zeros, okay, and that's where your graph crosses the x-axis. Okay, and the way that we find zeros, so we find by factoring and setting factors equal to 0, okay? And then we also need to talk about multiplicity, all right? And so in multiplicity, okay, is the exponent above each factor. Okay, if your multiplicity is, say, even, okay, then your graph is going to bounce off of the 0. Okay, if your multiplicity is odd, then you're going to cross. Okay. And so let's just kind of take a look. I want to talk about this. You know, this is just kind of what your vocab does and what all this stuff means. But I want to put this into practice here. And so I just want to look at, say, let's go to the next page and take a look at one of those examples. And let's go ahead and look at this last example here. And I just want to graph this function here. F of x is equal to 2 times the quantity x plus 2 squared times x minus 3. Now, the good thing is about this one is that this is already factored. Okay, so you have your factors here. You've got a factor of x plus 2 and x minus 3. So here's what I do. I write out my factors. Okay, and that's x plus 2 and x minus 3. Now, what I do to find my zeros, okay, is I take each of those factors and set them equal to 0. So I take x plus 2, set it equal to 0, and I take x minus 3 and set it equal to 0. Okay, once I do that, then I'm going to subtract 2 from both sides. I get that x is equal to negative 2. Here I would add 3 to both sides and get that x is equal to 3. Okay, now what I know about this is that the x plus 2, this factor here, has a multiplicity of 2. All right, so what's going to happen is we then have our multiplicity. All right, and my multiplicity here is 2. It's even, so this is going to bounce off the graph at x equals negative 2. Here my multiplicity was 1 because the exponent above that was 1, and so we're going to cross the graph at x equals 3. Now, the other thing we need to talk about is our end behavior. Okay, our end behavior, our leading coefficient here was positive, and that was a positive 2. Okay, and so the other thing we need to figure out is our degree. Now, here's what I've got, and this is kind of hard to figure out given this type of problem. When I think about my degree, I have to think about multiplying all of this stuff out and foiling all this out. And when I do that, I'm going to get as a result 2x cubed as my leading term. Now, how I got that was I did this. If I think about multiplying out x plus 2 squared, you know, that's going to become something like, x squared plus 4x plus 4, okay, multiplied by 2. If I multiply that again by x minus 3, you know, one of the things I'm going to do is I'm going to take x and multiply it by x squared. That's what gives me x cubed. And then I think about it, okay, once I multiply all that stuff out, I'm going to have to multiply the 2 into everything, and that's where that 2 comes from. Okay, so my leading coefficient is positive, but my degree is 3. My degree is odd. All right, so my end behavior is going to go down to the left, okay, and up to the right. Okay, so what I'm going to do here is put all this stuff together. Okay, the first things first is that I need to label where my zeros are. So I've got negative 2 and 3. So I'm going to plot those here at negative 2 and positive 3. Now, the one thing I know is that I'm going to have my end behavior go like this. Okay, and then I want to think about, okay, what's going to happen at each 0? Okay, at x equals negative 2, since my multiplicity was 2, and I got that from that exponent up here, it's going to bounce off. So at negative 2, we're going to bounce off, but at 3, we're going to cross because my multiplicity was 1, okay, because my exponent was 1. All right, so at 3, we're going to cross, negative 2, we're going to bounce. So watch what happens. So I'm going to do this, and if I label this, we're going to bounce off, and then we're going to cross at x equals 3. And that's our graph, okay? It's not exact, but it's pretty darn close, okay? And let me just log on to Desmos real quick and show you guys what that graph looks like. Okay, so here's the graph. And notice here that the scale of this graph is vastly different than the scale of this graph. But what I want you to know is that I have my point at negative 2, 0, and I have my point at 3, 0. Okay, notice how we bounce off at negative 2, and notice how we go through at 3. Okay, the other thing that we could find is your Y-intercept, and your Y-intercept can be found by plugging in 0 for x and then evaluating. And we could have done that, but I wanted to go through just the shape of this graph. I'm more concerned about you guys being able to find the shape of this graph than being terribly exact with, you know, finding your minimum value here and all that. So, I mean, we'll do that kind of stuff, but, you know, at this point, I just want you to be able to graph using information given to you. Thanks a lot. We'll see you. Bye.